In this module, let's look at EdgeConnect SD-WAN reference architectures. These are 4 recommended EdgeConnect reference architectures, and let's take a look at them each so that you'll have a basis for some well-known designs and recommendations for building your SD-WAN deployments. This slide shows EdgeConnect's branch office reference architecture. The appliance is deployed in path, therefore all packets arriving or exiting go through the appliance. This example only shows Internet and MPLS, but you could use LTE, dual Internet, or any combination of transports. This architecture eliminates most of the causes of asymmetric flows. An asymmetric flow is where traffic goes through a tunnel in one direction, but does not return in the same tunnel. More specifically, it usually does not go through the same pair of edge connects in both directions. The edge connect here can learn routes from any local network inside the branch via BGP or OSPF, and the appliance can be configured as a DHCP server, which allows you to replace a router or layer 3 network device as well at the branch. And the EdgeConnect appliance has firewall features for the WAN side. You can configure each WAN interface to allow all traffic, be a stateful NATed firewall, or only allow users at that site to backhaul data leaving the site via an SD-WAN tunnel. The Cloud Hub feature offers a utility to streamline the process of setting up resources in a cloud provider environment so you can deploy an appliance in a more efficient way, requiring just a few minutes to complete. Currently, there are 3 cloud providers supported: AWS, Microsoft Azure, and Google Cloud. There are certain prerequisites and limitations with each provider, and documentation on deployment for these providers may be found on our website. Access these deployments via the Infrastructure as a Service option in the orchestrator. And once deployed, the discovery and approval process are the same as any other appliance. This is an example of our traditional high availability reference architecture. Each EdgeConnect appliance has independent access and connections to all WAN side transports. Here we will use a primary backup or active-passive model. The second EdgeConnect simply sits and waits in case the primary appliance fails. You can configure SLAs on the EdgeConnect appliances so that if they lose access to any one of their transport services, they drop in priority. For example, if A loses access to MPLS, B can take over, provided it still has access to MPLS and other transport services. We recommend using BGP, OSPF, or VRRP on the LAN side to make incoming LAN traffic deterministically choose one path in an active-passive configuration. There are a couple reasons for this. One is to avoid asymmetry if you're using Boost. The other is to avoid overloading upstream routers. Each appliance is typically configured to take advantage of all available bandwidth. In an active-active configuration, an appliance wouldn't be aware of how much bandwidth was being used by the other appliance, and the combined throughput of the 2 appliances could oversubscribe the transport upstream, leading to congestion, lost packets, and network disruption. This is easy to avoid by using an active-passive configuration. This architecture is an alternative to our Edge HA architecture, which we'll describe on the next slide, and is typically used with data centers or large sites. While traditional HA offers excellent redundancy, it can be much more expensive because it requires WAN-side switches or routers, and each appliance needs its own IP address to connect to each WAN transport. This slide illustrates the EdgeConnect HA architecture. It provides high availability and flexibility while saving you money. 2 EdgeConnect appliances are connected over an HA link, and each appliance operates as an independent unit, providing transport services for its partner if it's required. As mentioned earlier, you could think of them as a virtual chassis. VRP, BGP, or OSPF on the LAN side allows the 2 EdgeConnect appliances to work in an active-passive mode. if one EdgeConnect fails on the WAN side, it still has full access to the other HA peers' WAN side interfaces. Now the goal here is not maximum redundancy. It's redundancy with cost reduction. The benefit is that each appliance no longer requires an interface and a separate IP address to connect to each WAN side service. In this example, Edge HA eliminates the need for 3 IP addresses and the need for WAN side switches as in the traditional HA reference architecture. So we're reducing costs while still providing some reliable connectivity and redundancy by requiring fewer IP addresses and allowing the use of another appliance's WAN links for link bonding. We can create an overlay over this internet and this MPLS transport with an Edge HA configuration. This architecture is typically used with larger branch offices or regional offices. Whenever possible, always try to make path selection predictable and deterministic. Remember, the goal here is to create rules with business intent overlays that are predictable and foresee the type of traffic that we're trying to manage both internally and externally. There are various methods which you will see used in upcoming classes. Things like admin distance and peer priority, as well as network protocols, and routing methods with route maps and policy-based routing. Let's go ahead and look at some review questions now and see how well you absorbed this module's information. Well, that's it. You've come to the end of the EdgeConnect SD-WAN Essentials course. Thank you for choosing EdgeConnect for your SD-WAN, and we hope the information from this course serves you well.